This section 6.5 on, we start with partial fraction decomposition. So let's write the function as a sum of rational functions with linear denominators. Let's factor the denominator. 2x and x, and then minus 3 and minus 1. And we're going to write this. We're going to write x minus 13 over 2x squared minus 7x plus 3 is equal to something over 2x minus 1 plus something over x minus 3. Well, the next step is we're going to get common denominators. So let's multiply the top and the bottom here by x minus 3, and the top and bottom here by 2x minus 1. Once we get the denominators the same, we just got to make the numerators the same. So x minus 13 is equal to a times x minus 3 plus b times 2x minus 1. Let's let x equal 3. We're going to make this factor right here 0. So 3 minus 13 is negative 10. This piece is going to be 0, and then 6 minus 1 is 5. Here we have 5b, so b is equal to negative 2. Let's let x equal 1/2. We're going to make this 0 right here. So 1/2 minus 26 halves is negative 25 halves. And then 1/2 minus 6 halves is negative 5 halves. So we have times negative 5 halves there. And let's multiply by, we're going to multiply by negative 2/5 on both sides. So a is equal to, well, the 2's cancel, positive 5. So the answer that we're looking for is we're going to have 5 over 2x minus 1. 5 over 2x minus 1. And then negative 2 over x minus 3. Negative 2 over x minus 3. And we've written this with linear denominators rather than a quadratic denominator. Anti-differentiating with partial fractions. So let's we're going to integrate, and we're going to use the technique to split this up into linear denominators. Now, we couldn't do this with u substitution. We wouldn't be able to do this one with partial fractions either. Or not partial fractions, but integration by parts. Let's factor the denominator, x minus 1, x plus 1. Oh, actually on this one, we have to divide first. If the powers are the same or the top one is higher, we have to do a little long division first. So we're going to divide x squared plus 0x minus 1 into 3x to the fourth, 0x to the third, 0x squared plus 0x plus 1. So we'll have placeholders for all the powers. X squared goes into 3x to the fourth 3x squared times. We have 3x to the fourth minus 3x squared, minus 3x squared. That's going to be 0. And 0 minus negative 3, we always subtract when we divide. 0 minus negative 3 is 3, so 3x squared. And let's see, the x squared goes into 3x squared 3 times. So plus 3. That's 3x squared, and then minus 3 over here. That goes to 0 when we subtract. 1 minus negative 3 is 4. So this is the same as the integral of 3x squared plus 3 plus 4 over x squared minus 1 dx. Now we know how to integrate this piece right here. It's x to the third plus 3x, but now we need this piece right here. So this is where we get into the partial fraction part of this problem. Let's factor the denominator, x minus 1, x plus 1. And we want to know this. 4 over x squared minus 1 is equal to something over x minus 1 plus something over x plus 1. Let's get the numerators to be the same. So we need 4 is equal to a times x plus 1 plus b times x minus 1. If we let x equal negative 1, then we get 4 is equal to negative 2b. So b is negative 2. Then when we let x equal 1, we get 4 is equal to 2a. So a is equal to 2. I'm going to grab this integral over here. I'm going to write it off to the right over here. So far, well, let's do this. We have integral of 3x squared plus 3 plus 2 over x minus 1. And then we have a negative 2 for b. So let's do this, minus 2 over x plus 1 dx. And now we can integrate all of this. X to the third plus 3x plus 2 natural log of the absolute value of x minus 1 and minus 2 natural log of the absolute value of x plus 1. Well, that's going to be a minus. So let's write this, x to the third plus 3x plus natural log of x minus 1 over x plus 1 squared, because we can bring those to the top. We can bring those to powers. There's the power, and then the minus turns into division with natural log, and then plus c. Finding 3 partial fractions. This example will be our most laborious problem. Find the general solution. The general solution. So dy is equal to all this mess over x squared minus 4, x minus 1, dx. And now we need to integrate both sides. So let's factor this x squared minus 4, x minus 2, x plus 2, and we have x minus 1. 6x squared minus 8x minus 4 over all of this, x minus 2, x plus 2, and x minus 1 is equal to a over x minus 2 plus b over x plus 2 plus c over x minus 1. Well, let's get the common denominator. We have 6x squared minus 8x minus 4 is equal to a times x plus 2 times x minus 1 plus b times x minus 2 times x minus 1 plus c times x minus 2 and x plus 2. We're going to let x equal negative 2. So we're going to cause this factor to become 0. So negative, let's see, 4 times 6 is 24 plus 16 minus 4. That's 2, 3, 40 minus 4, 36. 36 is equal to, this becomes 0. And over here, this one, let's see, which one becomes? Yeah, this one becomes 0. So we end up with b times negative 4 times negative 3. So b negative 12b is equal to 36. b is equal to negative 3. Let's let x equal, how about 1? 0, 0. This will not be 0. Well, let's plug 1 in over here. 6 minus 8 is negative 2. Looks like negative 6 is equal to negative 1 times 3, negative 3c. So c is equal to 2. Now let's let x equal, let's see, we were negative 2. We got 1. How about, what do we need? 2. We need 2 here. Make this third factor 0. So if we let this equal 2, this will be 0, this will be 0, and I think that one will not be 0. 6 times 4 is 24. 24 minus 8, let's see, 24 minus 16. 24 minus 16 minus 4. That's 8 minus 4 is 4. 4 is equal to, here we have 4 times 1, 4a. So a is equal to 1. Well, now this integral, we have, well, let's do this. Let's go y is equal to the integral of a over x minus 2. So 1 over x minus 2. B was negative 3. So minus 3 over x plus 2. X plus 2. And then c is 2. So plus 2 over x minus 1. So y is equal to natural log absolute value of x minus 2 minus 3 natural log of absolute value of x plus 2. and plus 2 natural log absolute value of x minus 1, and then plus c. This is going to be natural log of the absolute value of x minus 2. Let's do this. Over x plus 2 to the third, plus we have natural log of x minus 1 squared plus c. So that's natural log of the absolute value of x minus 2 times x minus 1 squared over x plus 2 to the third, and then plus c. In exercises 1 through 4, the values of a and b that complete the partial fraction. Find the values of a and b that complete. This is going to be 2x plus 16 is equal to a times x minus 2 plus b times x plus 3. We're going to let a equal 2. And we get 4 plus 16 is 20 is equal to 5b. So b is equal to 4. We're going to let, did I have a here? Oh yeah, a equals 2. Let x equal negative 3. Oh, we wanted x equal to 2 there. Anyway, x equals negative 3, which is negative 6 plus 16 is 10. And that's going to be negative 5a. So a is equal to negative 2. So negative 2 over x plus 3 plus 4 over x minus 2. Evaluate the integral. Let's, well, the derivative of this would be 2x plus 1. So that 16 is kind of messing up u substitution. So x plus 3, x minus 2. And so we have 2x plus 16 over x plus 3, x minus 2 is the same as something over x plus 3 plus something over x minus 2. So 2x plus 16 is equal to a times x minus 2 plus b times x plus 3. We're going to let x equal 2. 4 plus 16 is 20. And 3 plus 2 is 5. 5b. b is equal to 4. We're going to let x equal negative 3. Negative 6 plus 16 is 10. And negative 5a. Negative 5a. A is equal to negative 2. So now we're going to integrate negative 2 over x plus 3 plus 4 over x minus 2 dx. That's negative 2 natural log absolute value of x plus 3 plus 4 natural log absolute value of x minus 2 plus c. Well, we really want the negative 1 second, so let's do this. Let's go natural log of the, do I need absolute value? I don't need absolute value because both of these are going to be raised to even powers. So I don't need absolute value for this. Let's go natural log of, let's put this one on top right here at first, x minus 2 to the fourth over x plus 3 squared plus c. Over here, the derivative would be 6x minus 5, which is not a multiple of 1 minus 3x. We're going to factor. That's, how about negative 2 here and negative 1 there? Nope, that's not going to be negative 6 and negative 1. That's negative 7, so that's not going to work. I think I got it, though. 3x and x, how about minus 1 and minus 2? That'll be negative 3 and negative 2. That's negative 5. 1 minus 3x over 3x squared minus 5x plus 2 is equal to a over 3x minus 2 plus b over x minus 1. 1 minus 3x is equal to a times x minus 1 plus b times 3x minus 2. So we're going to let x equal 1. So 1 minus 3 is negative 2 is equal to, well, 3 minus 2 is 1. So B. B is -2. Now we'll let x equals 2/3. So 1 minus 2 is -1. And 2/3 minus 3/3 is -1/3. -1/3 A. So A ends up being 3. Well, now we're integrating A over 3x minus 2. No, not A, but 3 rather. Let's put the 3 in there. Whoop, erase that. 3 over 3x minus 2, and then minus 2 over x minus 1 dx. This is going to be the natural log of absolute value of 3x minus 2, because when we take the derivative of this, we'll get that 3 when we multiply times the derivative of the inside. Minus 2 natural log absolute value of x minus 1 plus c. So we have natural log of the absolute value of 3x minus 2 over x minus 1 squared plus c. The derivative of this would be 4x minus 3. So u is equal to 2x squared minus 3x plus 1. Du is equal to 4x minus 3 dx. This becomes the integral of 1 over u du, which is a natural log of the absolute value of u, but u is 2x squared minus 3x plus 1 plus c.